Hello everyone, this is lesson 5.6, Inequalities in Two Triangles. So for lesson 5.5, you learned about how the inequality theorem for one triangle, which just states that the shortest side is opposite the shortest angle and the longest side is opposite the longest angle. All right, so not rocket science, right? So this lesson for inequalities in two triangles is also a very simple concept. So to explore this concept, we're going to take a look at a GeoGebra applet. So here we've got, for inequalities in two triangles, the theorem is actually called the Hinge Theorem. So if you think about it like a hinge is like a hinge on a door. So the door and the door frame are always going to be the same length. So here we've got 6 and 8, 6 and 8. But depending on how far you open up the door, so the angle at which you open up the door will determine the length that you have to enter through the door. So the 7.6, notice that as we increase the angle that we're opening the door or decrease the angle that we're opening the door, that opposite side also changes its length and becomes smaller or larger, right? So here, if you have two triangles and they both have two sides congruent, if you look at the included angle, remember that this is called, if it's an angle in between, that's called an included angle. Included angle. So if the included angle of one triangle is greater than the included angle of another, then the third side of that triangle is going to be greater than the third side of the other. All right, so that's where our inequality theorem comes from, like the greater or less than part. All right, so here, go ahead and copy down the Hinge theorem and the converse of the Hinge theorem. So this says that if two sides of one triangle are congruent to two sides of another triangle, so the 6 and the 8, and the included angle of the first is larger than the included angle of the second, and the third side of the first is going to be larger than the third side of the second triangle, right? And then the opposite is still true. If two sides of one triangle are congruent to two sides of another, and the third side of the first triangle is longer than the third side of the other, then the included angle of the first is going to be larger than the included angle of the second. All right, so the regular Hinge theorem goes from angle, oops, that's supposed to be an S, to side length. And the other one, the converse, goes from side length to angle. Okay, and I suppose here instead of larger, you can say longer, just because that's how the converse is worded. All right, so but they're the same thing. All right, so let's look at some examples. So complete the statement with greater than, less than, or equal to. So for number 1, TP would be what in relationship to AG? Well, since you've got two sides congruent and the included angle is the same, they would actually be equal. All right, so number 2. So the measure of angle 1 and the measure of angle 2. Sorry guys, I got a bug in my throat. So the opposite side of this one is smaller than the opposite side of this one. So angle 1 is actually going to be greater than the measure of angle 2. All right, DE and EF. So DE and EF. Okay, so you've got these two sides congruent and the sides they share congruent. Excuse me. And then this angle is smaller than this angle. So ED would be smaller than EF. All right, for this one, so you've got the 18 that's congruent and then the side that they share. So here we're talking about the relationship between angle 1 and angle 2. Well, since angle 1's opposite side is larger than the opposite side of angle 2, then the angle measure is going to be larger. All right, so pretty easy so far. Let's look at this example. So we're comparing angle 1 and angle 2, and 12 is congruent. And since this is isosceles, what they share is congruent. and 6 is less than 7, so angle 1 is going to be less than angle 2. All right, and we're going to skip number 6 because that one's confusing. Number 7, the measure of angle DBF. So where is DBF? DBF, so we're talking about this triangle right here. And we're talking about this angle. So the sides are going to be 9 and 6. And this is the included angle. And then angle ABF. So then the other one is A, B, and F. Right, so then you've got 9 here and 6 here. Okay, so we do have the Hinge theorem, the first part of it, that two sides of one triangle are congruent to two sides of another, and we're comparing their included angle. So since 8 is less than 10, then this angle is going to be less than the other one. All right, so I think you've got the idea. There's just one more kind of setup for inequalities, and that's with like actually making equations, or inequality equations. So for this one, they both share this side. Okay, so we're comparing this one and this one. So what kind of inequality can you create? Well, since you know that 38 is going to be less than 3x minus 4, because 4 is less than 5, then you can say 38 less than 3x minus 4. So you can add over the 4 to be 42. And what's 42 divided by 3? Is it 14, I think? 14. So that means 14 is less than x. So you can say 14 is less than x, or you could say x greater than 14 if you flipped it around. Okay, so either of those would be the same. And then how about for this one? Let's see. Well, these two angles are not the same. So let's figure out two angles that would be the same. Oh, wait. Hold on. Okay, so they share this side, and then this side is congruent. Okay, so we're comparing this angle with that angle. Sorry, I was getting confused at first. And then, so the inequality that we'd create is that this is greater than this one, because this angle is greater than that one. So 3x plus 1 greater than, just x plus 3. Okay, so rearrange your equation. 2x equals 2, x equals 1. All right, so I hope you've got the idea. To keep this lesson simple and short, that is going to be all. Okay, you'll do more examples in the Elastic, and I hope you have a great day.